This is the last new lesson we have. Oh, you don't? We'll use my little math bingo card. Okay, think of a deck of cards. This is math bingo cards. Okay, you guys in the front row? You're clearly identified now. Imagine a deck of cards, you know, as you get more cards. How many decks do they use in Vegas? Six. It's pretty tall. Can you find the volume? No. Can you find the volume of the deck of cards? Could I find the volume of this deck of cards? I'd find the volume for one of these little slices, and then I'd multiply by how many I have, because they're all the same. Okay, guys? What we're going to do is create volumes in a different way. What we did already was we rotated. We took a curve like this, and we rotated it around an axis. And when you rotate a curve around an axis and you slice it, you get what shapes? Circles, right? Circles. But we can get solids by creating this with cross sections. Okay? And they might not be square cross sections. I'll give you an example of one. You guys ever play the Tower of Hanoi? Oh, you know what it is. Did you ever play that game? Now, is there a volume here? These cross sections are what? Well, what shape is the face? It's a square. Okay, you guys, you need to be listening so you get this. It's not that hard to get. But those are squares, and the thickness is pretty thick, but you can kind of see this is going to go up into a pyramid shape, isn't it? Yes, no? If you found the volume of each one of the little squares and added them up, you'd have the volume. Well, it's exactly what we're going to do. Don't get hung up with what the figure might look like. Okay? Okay, so on a deck of cards or my math bingo cards, they're all the same size. Well, in my picture I'm going to do now, they're not all going to be the same size. They're going to look something like this. This is problem number 6 in the big thick packet, where they are square cross sections. And yeah, I know, but it's barely hanging there. Okay, so they're going to come out at you. And they're going to be this weird shape. I don't really care what it looks like, though, because that's not important. The important thing is I want to find the volume for one of the cross sections, guys, and add them all up. That's all I want to do. So I like these better. They're actually a little easier to do. Okay, so I'm going to try and draw this. This is not fun to draw. So I'm going to draw my 3D picture over here. Actually, and my two-dimensional picture here. Yes, this is the very last problem. And we need to finish the problem before it, so I forgot about that till just now. Oh, that's not why. This is Z. Sorry. This is Z. And this is Y. Okay, so it's hard to draw. It's easier paper pencil, which is what you guys have. Okay? Yes. It's three-dimensional. Yeah, it should be going on should have the same slope as that. In fact, this one, if you want me to put all the dotted lines in, I can. Then this one would go this way. I'm going to draw it. You'll see it when I get it drawn. And this is going down. That's how you draw 3 dimensions. Very hard. I don't have the 3-dimensional pen, but maybe someday I will. Those are just the axes. I haven't drawn anything yet. Okay, first let's do it 2-dimensionally, and then we'll do it 3-dimensionally. So this is the base of my solid. It's in the first quadrant, and it's bounded by this parabola, the x-axis and the y-axis. So when x is equal to 0, what's the y value? X equals 0. Put it in here. It's 1. So I have the point 1 here on the y-axis. Well, the other nice place, because I know it's a parabola, it's upside down, because it's negative, is to find the x-intercept. The y is 0 there, and I'm not going to solve that. I'm not going to go through the process. I'm just going to do it by inspection. Because when you solve, you're trying to find numbers that make a sentence true. If you can just see the answer, that's wonderful. So it's 2. Right. So it's an upside-down parabola that looks like this. And you have these cross-sections that are square. So you're going to build it with these little square regions here, volumes. And they're going to come out at you like that. That's there. You can kind of visualize what it's going to do. But I don't care what it looks like, because it's just not important. Why is that doing that? Power through my hands. Okay, so I'm going to draw one of the sides of the square. You see? If I had that three-dimensional pen, I would draw it out like this and connect it. That'd be kind of cool. It's already invented. Okay, so this is going to be my thickness. Now it says it's perpendicular to the x-axis. Is this going to be delta x or delta y? Delta x. Now I'm going to draw this square cross-section. It's going to look like this. So each one of these little squares has a thickness to it, which is, that's delta x, that thickness. And then this is the side and this is the side. What's the volume for one of these? Times what? No. S squared. It's the volume of this square that I'm holding up in my hands. So it's going to be side times how thick that little square is, which is delta x. We'll make it really thin, not like the Tower of Hanoi. Because that wasn't a very smooth pyramid, was it? Wasn't, was it? Okay, now let me see if I can draw this thing. It's tricky to draw this. After I've drawn it, I'm hoping you can see that. Well, let's try green. And it's perpendicular to the x-axis, which means it's parallel to the y-axis. You don't have to draw it. And there are some nice drawings in the book. And there are probably some nice drawings online as well. And if you were to connect the little corners, they're going to come down into a point here. That one's not quite. Well, that's a nice place. Now I got to stand back and look at it because I can't tell. Oh, that's not bad. You have to, well, I don't know if it's exactly an 8. Remember those magic eye pictures? You're going to have to relax your eyes so you let yourself see it in 3 dimensions. It's hard. What's your question over there? This is not calculus, this is geometry. We're not rotating it. We're building it. Because they told us to. Okay, there are 2 ways to create solids here. We can rotate a curve, which may be what they do to get a football the right shape. I don't know, but I'm sure there's mathematics in that. Because all the footballs have to be the same, don't they? They do. So there's a machine, there is an equation, I'm sure, that they use for the football. And you could find the volume. And when you slice things, you rotate, you get circles. This was not created that way. Go back to the Tower of Hanoi. This was created by, or a deck of cards, it was created by adding up all these little squares. I could make them smaller and smaller, stack them on top of each other. But the Tower of Hanoi really helps. So you can kind of see it here. But I don't care what this volume looks like, what this solid looks like. I just care that the cross section is a square. Okay. Okay, you guys? Jacob, get that away. We're doing math. I know. What is the side in terms of my picture? What is this equal to? That's S. It's equal to what? X or Y here? It's equal to Y. You have to read the problems carefully so that the volume for one of these is going to be side squared delta x, or in terms of my equation, it will be y squared delta x. These are always going to be opposites. So when you get y squared delta y, you know you did it wrong. Okay, so then when we integrate them, this is the calculus. We're going to integrate this. Is there going to be a pi in my answer? No, no pi. So it's y squared dx. And now let's go ahead and figure out what function we're going to work with. It was at 1 minus x squared over 4. That's my y value, right? And you're going to square it. Is it easy to miss that squared? Yeah. Dx. And then this is the variable we want. So what are the x's doing here? They're starting here when x is 0, and they're moving across. They're getting smaller until they get down here to x equals what? Where was it? No? Y equals 0. So it goes from 0 to 2. And you're done. Now, last class said, why doesn't it use substitution work? Well, if I let u equal 1 minus x squared over 4, then this would be u squared dx, right? Remember, you have to account for everything. So I have to find dx in terms of du. So du is equal to, what's the derivative of that? Negative 2x over 4 dx. So du is equal to negative 1/2 dx. So if I solve for dx, dx is equal to negative 2, what, I missed my x there, sorry, negative 2 divided by x du. If you go ahead and put this in here for dx, I still have a problem. I have u squared, and I have a negative 2 over x du. What's the problem? I still have an x. And finding x actually makes it a harder, well, it might be doable, but I'd have to solve that equation for x in terms of u, and then I think the integral is going to be nastier yet. So the only way I can think of to do this, if I want to do it by hand, is to multiply that out. So if it's to the 100th power, I'm in trouble. Can't do it. I would then get my calculator out and just calculate it by doing it numerically, adding up all those little areas.
So why do you draw the picture in a problem like this?
Because I won't get the problem right if I don't draw the picture. What? This is, the square is coming out at you. So how do you find the length of that segment? It's the y coordinate. Next question. Oh, so helpful, but you won't, I don't think you'll get it right if you don't draw the picture. Because some of you will do that on your test next week. You won't draw the picture and you're going to get it wrong. I can't do it without drawing a picture. Notice it's just geometry. The calculus is saying, let's integrate it, and then integrating it either by hand or with the calculator. That's all the calculus there is. Okay, that's the last lesson. So let's do the first problem out of that packet. Remember the packet with all the AP questions in it? We were working on it with the areas. You were assigned all the areas. Now, you want to pass the AP exam. I don't care what you want to pass it with, but it's not going to happen unless you practice. We have, today's Tuesday. We're going to do 1.5 problems today, maybe just one. I don't know, we'll see. So we'll do a problem today. Tomorrow is Wednesday. You can work in class, or you can ask me questions to put on the board, however you want to do it. It doesn't matter. So tomorrow is going to be working on problems. Thursday's working on problems. Friday's working on those problems. And Monday next week is working on those problems. If you do all those problems, I think you have a really good chance of getting a 95% on your tests next week. Tuesday, Wednesday. If you're going to be gone, if you're going to leave early, the test is ready. You just need to work on the problems. All the material's been taught, so you could take it ahead of time. And we have a partner quiz Thursday or Friday. I'm not sure which day we're going to be doing it. I'll tell you tomorrow. And then after break, we'll come back, and we'll probably start with limits. Review. It's also a nice calculus video, calculus in 20 minutes. Watch that. It's funny. It's on YouTube. You can do that too. Certainly on Friday. Maybe we should quiz on Thursday. Okay. Shall we do the first problem. This takes me a while to draw, you guys. Are we ready? We did the area, and I'm going to borrow a sheet here. I don't need to borrow it yet. And I'm going to take some time and draw it. And we're going to rotate. Oh, I don't want that. Okay, you guys? Draw the picture. You're going to rotate around the line y equals 1. Number 1 on this packet, area and volume packet. I don't have any more of these. Everybody's taken mine. Now I'm going to change these colors. Whoops. There. Will be the same colors in other class. Okay, let me label this. This is the x-axis. This is the y-axis. This is y equal to 1. It's the last lesson. Okay, we have a couple graphs here. We have this graph. Yeah. There we go. And we want this region right here. We did A. Now we're going to do B. Okay, we are going to rotate that colored region around y equals 1. So when you slice it, because it's rotating around, what shape will we get? I meant to bring my apples today. I forgot. You're going to get a what? Circle. Could be a circle with a hole in it. Anybody do the ceramics with making the bowls? With the wheel? And you start with a mound, and then you scoop out the stuff, or you push it out to the side. There's a hole in it. It's just like that, actually. And notice that they're rotating that to get your solid there. So, okay, I'm going to do my best I can. I'm going to copy this, and then I'm going to wheel. And we're going to flip that.
Wait, is it going?
I just flipped it. It's going to go around like this. So imagine, okay? What did I just do? Did I just ungroup it? I did. How is that possible? It's like this. So you're doing your ceramics. This is coming out around like that. In the middle, you're pushing down on it, so there's a hole in the middle. Right? Okay, so I'm going to rotate it back because that's where it is. And then we'll draw it in there. Whoops. Okay, so we're going to draw. This is going to be the opening here. That's why there's nothing there. And then we're going to draw this here. Actually, if you don't make them too big, they're easier to draw. And there's a hole right there in the middle. I like to find my differential first. Okay. The tricky part's going to be the radius. It's all geometry. I just want to see if I can see it. Oh, I can kind of see it. Okay. What's the differential going to be? Delta x or delta y? That's this length right there. That's the change in what? The x-coordinate. Is that okay, Noah? Okay. So what's the volume for one washer? It's pi, big radius squared minus pi, little radius squared, delta x. So what you're going to do is find the volume. If I take this figure right here, this bottom one, e to the minus 3, remember the mound you start with in ceramic class? I want that volume, and then I'm going to take away the middle. And if you were to slice it, that's how you actually get the ceramic piece off the board you take a wire and you slide it on the bottom. But if you were to pick up your ceramic piece and look at it, you got a bowl. You got a circle there. If you look at it the other side, you've got a circle with a hole in the middle. So we're going to take the big volume and subtract off the inside volume. That's all we're doing. Okay, here's the hard part, getting the radius. And this is geometry. It's really not that hard once you see it. So let's do the inside radius. That's this one. This is little r. That's r, that length. Does everybody see what length I'm talking about? That is not the y coordinate, is it? Okay? Lauren. This is the little radius. This is what's new. This is hard. This length is 1. This length right here is what? All the way down to the bottom here. Forget the other curve. In fact, if I were to pull that out, I have this line, and then I have this curve, and here's the axis. So here's the radius. It goes from here to here. This is the y coordinate. This is 1, and this length is r. What can you say about r plus y? So how do you find the radius? It's 1 minus y. It could be plus, it could be minus. I have to draw the picture to figure out what it is. It's not always going to be the same. Most of the time it's going to be like this, but not all the time. And let's call that one y1. I don't care what you call either one, but we'll call this curve y1. If you clearly define y1, that's great. Let's do the next radius. That's the radius from the green line down to this one. It's call that capital R. What's this length right there called? Y what? 2, because you're taking the distance from the axis to the curve. Try to make it a little bit different. I'm not doing a very good job, but so what's true about the capital radius? What's that going to be? How do you find this length here? You take 1 and you subtract off that y. You see that? Yes, no? Can it? It's geometry. If you want to write it this way, if I take this y2 value plus the big radius, that will get me up to 1. Solve for r, 1 minus y2. That's the hard part. Well, I don't know. I can figure that one out. Is that okay? It's just geometry, because I need to have the radius. Somebody asked, why would I do that? I want the radius. The radius is not, before it has been. When you rotate it around the axis, it was y, but now it's not. I'm rotating around something not on the axis. Now I have to do some geometry to figure out what the radius is. Okay, so it's pi big radius squared minus pi little radius squared. So the volume for 1 is pi big radius squared, which is 1 minus y2 squared, minus the little radius squared, 1 minus y1. You're right, I need to know what those guys are. Times delta x. And then we will integrate that. So the volume is equal to pi, and we'll integrate 1 minus y2 squared minus 1 minus y1 squared, which is only part b, dx. What variable do I want? I want x. So I don't want y2 and y1, so I'm going to go over here and figure out which one's which. Now y1 was this curve right here. So that's the square root of x. y2 was then, is it e to the minus 3x? There it is. Now, if you write in your problem what I just did, you could be done. You just have to put it on your calculator. There's a couple ways to do it. You could put this in y1 and y2, or you could put this whole thing in y1 and y2. It's up to you. Because what you would do with you would type in 1 minus y2 quantity squared. Exactly. Which is why you really kind of want pretty print. And what do the x's go between? Now, remember this problem? We did it a while ago. They go from the intersection, and that, if I recall from the last class, is approximately 0.238. You need all the numbers. You will have stored it in your calculator. It's probably in my calculator. find the intersection of two curves with your graphing calculator. Okay, so we're going to integrate from A to where? 1. I'll slide this up so you guys can see it. It's small. And then let's go ahead and put in our functions. If you have defined what y1 and y2 are on your paper, that will work. You won't have to put them in. But I'd like to have it look nice, so I'll put it in. A to 1, what was y1? Was that the square root of x? Because I like to have it look nice. This is the square root of x, quantity squared, minus 1 minus e to the minus 3x, quantity squared dx. Now, do you see why I go to this generic notation? Because looking at that, I don't see what the radius is, really. I see it better here. That's the reason why I do it. And if you work through this, you don't have to be so redundant as I am, but if you work through it, you should come up with the right answer. That's 3 points. Now, I have to draw this again because we're going to do the next part of the problem. So I'm going to tell you what the next part of the problem is. If what? You have cross sections. No, it's not revolved for part C. What is it? Read it. Somebody want to read it? Each cross section. Okay, so there's y, there's x equals 1, and there's y equals 1. And let's see, I have this figure here. Whoops, it's supposed to go up there, and that one there. Okay, so this shaded region is going to be, guys, this is new. This is what we just did today. That shaded region is the base of my solid, and I'm going to build it with cross sections of these little squares. Well, no, they're not squares. What are they? They're rectangles. So let me draw this. In fact, this is not a rectangle. My little math bingo cards are rectangles. Okay, that's the base. See how it's going to be? And this rectangle is going to get bigger. So how do you find the area of a rectangle? It's base times height. And the base is this length right here. I'm going to tilt it over. There's base, and there's my height. And so what's the base equal to? This one we called y1, this one we called y2. Yes, the base is y1 minus y2. Is that okay? And then it says the height is what? 5 times the base. So I'm going to have 5 times the base, which is y1 minus y2. Sorry. Can I move that a little bit? There. Or it's 5 times y1 minus y2 what? Okay, it looks kind of similar to the other one. Will you have a pi in the answer? No. You get the pi because the other ones were rotated. Think of that wheel in the ceramic class. It's rotating. You get circles. It's all circles there, isn't it? Have you ever flown over the west, like out on the way to Colorado, and you look down out of the plane, see all the circles in the fields? You ever notice that? The same thing. I used to make perfect circles when I tie my horses out. I'd stake them, and then they would do a perfect circle around because they would always eat the grass. They were the best lawnmowers, except they won't eat the weeds. Horses are smart. Well, sort of smart. So how do you find the volume of this? It's the area of the base. It's this thing. Pigs are very smart, yes. Times the thickness. Is this delta x or delta y? What is it? Delta x or delta? Zach, what is it? It's this length right here. Is that the change in x or the change in y? Yeah. It's all geometry. And then what are we going to do? You're going to integrate y1, and we've already defined what they are, but we could fix it, dx, and the x's go from where to where? Guess what? It's the same problem, almost. They're going to start over here at that value, which we called a, to 1. So let's put the functions in just so I know what it looks like. And see, y1 was the square root of x, right? Minus e to the minus 3x squared dx. It's this one, which is the square root function, minus the exponential function. And would you like to see the scoring rubric? Because I have it here. Let's see if I can, I can't do this. Okay, and there it is. And the thing is this is just a small picture. Actually, I think I'll get rid of that. Okay, we get briefed on this about an hour to an hour and a half. We sit and we look at student samples, we take notes. This is just a rough outline of how they're going to grade it. But if you have all of this here, you got it. You may get it in different ways. So this part right here, it's 3 points for your volume for part B, 2 points for the integrand. Okay. Can you get negative points? No. Maximum you can lose is 3. So let's say you've got your radiuses reversed. You'll know because your answer will be negative. Then what do? You don't rewrite it, or you could cross it out and rewrite it, but do not erase. Whoops, didn't mean to touch that. Because some people like to have things really, really neat. Okay? This is not, I want you to have it neat so we can read it. This is not the time to erase and make it perfect. You don't have that kind of time. But you could just put a negative sign out in front right there, and if that answer is negative. It's okay. It's mathematically correct. But if you reverse it and you don't fix it, you're going to lose a point. If you omit the 1 in the radius, you will lose a point. Now, I don't know if they're going to give you the answer point. Looks like they will. That means we have our calculator sitting with us, and we put that in our calculator, whatever you put in there, or they may give us the answers. Sometimes they just say, here are the answers if they do make this mistake. And if they make this mistake, these are the answers. Because everybody's doing the same kind of mistake. But if you reverse it and you forget the 1, you're not going to get anything. No, reverse these two. Because it's big R squared minus little r squared. So if you switch those around by accident. Okay, Jack? So that's not too bad. We got all 3 points there, I believe, except I didn't integrate it. Oops, a little too far. And then this one, you get 2 points for the integrand along with the rectangular cross sections. If you give the difference of square root of x minus e to the minus 3x, you get a point for that, even if you mess up with the 5 and the squaring. So if you have the square root of x minus e to the minus 3x and you forgot to square it, you will get 1 point out of that. Like I said, I haven't graded one of these, so I don't know how rigid they are. If you don't get the right integral, they may not give you the answer point at all. I just don't know. So try not to make those mistakes. But these are easy problems to get points on. And this is usually where people get the highest scores. At least here, that's true. And same with the differential equations. If you get those out, you got 2 problems out of 6 down. And then you're going to have an FTC. And you've seen those. You're going to have a max and min. You've seen some of those. And we'll go over it. We have everything grouped by topic. So we'll come in, and maybe 2 nights we'll do the FTC, because that's so important. Because there'll be 2 to 3 problems involving the fundamental theorem of calculus. Some way, shape, or form. So I suggest that you do problem, or we could do problem 2, or we could do this problem. I forgot what we did. So we still have some time. So do you want to try it first? Yeah, we did problem 2. Can I borrow that?
Yeah.
Okay, so I'm going to go to the next page. And this is what we're going to do. Either you can work in class, or I can do problems at the board. Now, before I do 2, I'm going to read it. 2b, I'm going to revolve around the horizontal line y equals 2 And this graph doesn't even go up to 1. So I've got to be careful how I'm going to draw this. Otherwise, I'm not going to have enough space. And I'm not going to try and draw it too large. This was a tough one, I thought, to draw. Okay, and then we'll make y equals 2 right here. And we'll make that red. Okay, let's see what we got here. I've got this picture. I still have it too big. And then this one. So I'm going to clone that. Uh-oh. Okay. No, it's not going to work because I have that line there. Oh, wait, maybe I can erase it. No, I can't. Oh, yes, I can. Oh, wait, I know how to do it. Okay, that didn't work. Wait a minute. There we go. And then we're going to flip it. So you guys should be trying to draw it. But see, here's the problem. This gets to be a big picture. Does that look about right? Same distance? You always draw your rotations to the original problem, which is down here. This one's tricky to get the radius. Kind of a weird shaped donut. And so when you do this, they've got this too big, then you're going to have this. They should have done it smaller, but this is just a tough one to draw because it's so big. Easier with paper pencil. Okay, you can kind of see it. It's what, a washer or a disc? It's a washer. Okay, what's the volume for a washer? Pi, big radius squared. You're going to find the volume of this curve going around, and then you're going to take out the donut hole. Minus pi little r squared. Delta x, delta y. Which one? Hey, Declan, you should be doing this. Jack, you should be doing this. This is delta x. Otherwise, you're going to have to watch the video later, which is not fun. I'm not even funny today. I know, I'm not funny any day. Okay, let's find the little radius, because that's this one. That was the easy one. How do you find that length? Remember, this length is how big? 2. This length here is the y-coordinate on that curve. Okay, I got one answer. Is that right?
Yeah. Where?
No, I'm just getting the little r. I'm just getting the radius.
Oh.
So the little radius is this whole length minus the y-coordinate here. And I'll just get that piece there. Now, the next one is not intuitive, but we're going to do the same process. If you think about it, here's the big radius. And I had to think about this. This length is y2. But what's true about y2? Well, it is, but it isn't. What's going to be true about the sign of y2? It's negative. So y2 is less than 0. I can't add the 2 on there. I have to do for the big radius, it's 2, and I got to get that positive, so it's subtract y2. Let's pretend this is a negative 9. Just pretend, because in some place it is probably. So I want this full length. I'm not going to do 2 plus a negative 9, am I? No. I have to have 2 minus a negative 9. So it's going to be when you do this, it's going to be the full is this number minus that one. You just have to look at the picture. I can't say it's always one thing or another. But that's what it is. So my volume is going to be pi, big radius squared, 2 minus y2 squared minus little radius squared, delta x. And then we're going to integrate it. So the volume is equal to pi. This is the calculus. 2 minus y2. Now, y2 is the graph that goes underneath, and I don't know what the name of that function was. Oh, thank you. Could I just write g of x?
Yeah.
Yes. If it's clearly defined, not, I'd rather. And as a reader, honestly, I'd probably rather read it. Minus 2 minus, and the other one, my guess is f of x? Yeah. Squared dx. And from where to where? Look at your picture. My picture's not clear. 0 to 1. It's going to start over here, and it's going to end over there. Notice I always draw my radius to the original figure, not the rotated one. Yes. I didn't know it was labeled that, so I just did it. Okay. Now, you've only seen this like 2 times, 3 times now. That's not very much. That's, well, you have to integrate it.
You always have to.
Not always. You have to read the directions. If it says set up but do not integrate, then I don't have to integrate it. I love that. Actually, I'd rather integrate it. Why? No? Hey guys, listen up. Why would I like to integrate it, Noah? Because if I integrate it and I get a negative answer, then I know my setup is wrong. No, we don't. But it's easy to get the functions mixed up. So if you integrate it, get a negative answer, then put a negative out in front, and you'll get your full 3 points. Don't write down a negative number. Okay, let's do the last part. Okay, guys, the last part is the same question, but with a K in it. Okay, I got to borrow this, sorry. Oh, you got one right there. Well, he's not using it. Okay, let h be the function, and you're going to say this isn't the same one, but yes, it is. Okay, it is the same function. You guys, this top curve was, f of x, which was 2x, 1 minus x. All they did was take the 2 and make it a k. So it's the same shape. They say it's not drawn, but it's drawn. It's good enough drawing. So I'm going to have this. That's going to be a k there. I don't know how tall that is. Who cares? I still have the same basic shape. K is positive. Okay, don't throw, please. It's the base of the solid, square cross sections, perpendicular to the x-axis. So which way are we going to do it? Perpendicular to the x-axis will be this way, right? Okay, delta x, delta y. Look at that. Is that the change in the x or the change in the y? Delta x. How do you find this length? That's your side. It's this y value. In the top one was f, right? And this is g of x. So S equals F minus G. I don't have space to put the x's in it. Oh, that's not so bad. There is a value K for which the volume of this solid is equal to 15. Right, but do not solve an equation involving an integral expression, meaning an integral, that could be used to find the value of K. So these are square cross sections, so they're coming out at you like this. You know what the side is. What is the volume for 1? What's the volume of this little square piece? It's side times side times delta x. So it's going to be, like you said, it was f of x minus g of x and we're going to square it. I almost forgot to square it, delta x. So what's the integral going to look like? The integral of f of x minus g of x. Careful not to distribute those squared because it doesn't distribute. Well, some people like to, but they're wrong. That's wrong. And then where do we go from? Yeah, it's still 0 to 1, isn't it? Is that all of that? Oh. And that says the volume is equal to 15. Except, you know what? It isn't f of x, is it? No, it isn't. This was not f of x. This was h of x. H of x had a k there. So I better fix that. So I'm going to erase my f of x's and make it. I'm not going to erase. I'm going to cross out. It's h minus g. Here I'm going to erase because it would take me too much work to fix this. Now, h of x has the k in it, so I really don't care if I write down the function or not. What? There it is. Do you want me to get the scoring rubric for this one up? That's the answer. Right. You probably can't integrate it. Because it said it was 15. It says there is a value k for which the volume is equal to 15. Right? But do not solve. You can't without a k. Well, no, you can't without a cast because it's got a k in it. Because this is kx 1 minus x. And then it would be a lot of work to do minus whatever that other function is and then square it out. I don't want to do it. That's why they said set up but do not solve. Oh. What's your job? Work on these problems. Bring questions in. Work in class. Even if you just work in class, you should get all these problems done. Shouldn't be a problem to get them done. And we don't give you any homework over break.